You're watching this video, Introduction on Functions, on behalf of Mathail. If you find this session helpful, please do hit the like button and subscribe. A function is a relation in which each value of independent variable corresponds with only one value of dependent variable. That means for each value of domain, we should have single range. That is, it can be denoted as f such that a to b, where a is an independent variable and b is a dependent variable. So whenever relationship exists between two variables, we say that the second variable is a function of the first. So here, second variable b is a function of a. The first variable is called independent because different values can be assigned to it, and the second variable is called dependent variable because its value is determined by the choice of the values taken by a. So because it takes the value according to a, that is why it is called as dependent variable, while this can have its own value, so it is called as independent variable. Function notations can be f of x, g of x, h of x, s of t, h of t, g of y. Anything can be represented as functions. For example, f such that x to y. So function is from x to y can be written as f of x equals to y. And because y and fx are interchangeable, so we can write it as y equals to f of x, where y is a dependent variable and x is an independent variable. For instance, if f of 1 equals to 3, then what does it mean? That means that f of x takes value of 3 at x equals to 1. So at x equals to 1, it takes the value 3 of the function. So f of 1 equals to, this is nothing but f of 1 equals to 3. So at x equals to 1, the value of the function is coming out as 3. That is the meaning of f of 1. Or we can write it as point lies on the graph of f is 1, 3. So 1, 3 is an intersecting point which can be written as f of 1. In the terms of function, we can write it as f of 1 equals to 3. Or we can say it as 3 is dependent variable. 3, so it's not a variable here, it's a constant. So 3 is independent on 1. So 1 is independent while 3 is dependent. According to the arrow diagram, we can show it like this. This is showing domain set and this is showing range. So here the range is 3 and 1 is the domain. So and f is the function. So f is the function from domain to range and this is from 1 to 3. So 1 to 3 is the thing. So these are the ways to represent. Representation through a mapping diagram or an arrow diagram. So if A is any set with elements 1, 3 and 1, 3, 7 and 9, and B is any other set with elements -1, 0, 2 and 1, then with the help of arrow diagram, we can see that this is the relation. So the relationship is between 1 and -1, 3 and 0, 7 and 1, 9 and 2. So we can say that these values are known as set of domain, while -1, 0 and 2 and 1 are nothing but values of dependent variable, which are nothing but the range. So let us understand with the help of examples whether the relation is a function or not. This is very important to understand. Like the first relation is 2, 1, 3, 1, 1, 4, 4, 5. So we can see here that 2, 3, 1, 4 are domains, and each domain has different unique images. Like 2 has one image, 3 has one image, 1 has 4 image, 4 has 5 image. So that means each element of the domain set has its individual image. So it is a function. Next example is -1, 1. -1, 1 means -1 has image as 1, 2 has -2, -3 has 3, -4 has -4. So we can see that -1, 2, -3 and -4 are elements of domain which all have unique images. If the images are unique, that means we can say the given relation is a function. So this is also function and this is also function. Next is r equals to 3 minus 2, 3 minus 1. So 3 has -2 image and this 3 has -1 image. So according to the function, this cannot be true. So 1 is having the image as 2, 4 as 5, 2 as 3, 4 as -1. Again, here also 4 is having image as 5 and 4 is having image as -1 also. So according to the function definition, it cannot hold true. So -2 has 3. So because 1 minus 2 plus 2 are elements of domain of R having unique images, but 3 and 4 corresponds to two different images. Because they corresponds to two different images, that is why this relation cannot be a function. So let us see the same example with the help of an arrow diagram. Here, arrow diagram is an easy representation. So this picture and it's easy to understand. So 2 1. So 2 1 is here 2 1, 3 1, 3 and 1, 1 and 4, 1 and 4, 4 and 5. So here we can see that each value, each element of domain has different images, different images. So it is a function. Now here -1 1, -1 1, -2 and 2, +2 and 2, -2, sorry, -3 and 3, -4 and -4. So this is a representation, but we can see that yes, every element has different images. So yes, this is also a function. Let's see the third example. 3 minus 2, 3 minus 2, 3 minus 1. So 3, the same value has -2 and -1 as image. So it is not a function. So we can say that this is not a function. Identify whether the given relation is a function or not. So we have to check whether the given relation is a function. It is in the form of arrow diagram. So arrow diagram, it's easy to understand. Let us see whether the given thing is a function or not. So let us see. 1 is having image as -3. So f of 1 equals to -3 and also f of 1 equals to +5. So according to the definition, it is not true. According to the definition of a function, it is not true. For each and individual domain value, we should have individual ranges. We cannot have two range for a same value. So it is not a function. Let us see here. 1 is having +9, 4 is having 6, 3 is having 8, and f of 2 is 7. So every domain set, every elements of domain have different images. So this is a function. Next example is my f of -1 is +7, f of -2 is +6, f of -3 is 3 also and 2 also. So again, it has two images. That is why it is not a function. Next, f of 8 equals to -1, f of -9 equals to -1, f of 5 equals to +6, f of 4 equals to -1. It is possible because f of 8 is -1, f of 9 is -1. So we can have same range for different domain sets. But we cannot have for same domain, we cannot have a different range set. So this is a function. So we have studied that function can be represented in different ways. In words, in terms of tabular form, in an ordered pair, when we define relation, mapping diagram or an arrow diagram, a graph, which we'll be going to study further, an equation which can be converted in terms of graph or table, then also we can find out whether the given relation is a function or not. Let n be a natural number and the relation R is defined on n such that R equals to AB, such that B equals to twice of A, and AB belongs to natural number. So we have to start, in order to see whether the given relation R is a function or not, we have to proceed with the given relation, which is this. So B equals to twice of A. B equals to twice of A is nothing but B is double of A. When B is double, then we can formulate the table like this. B is double of A. So this is, if A is 1, B is 2A. So 2 into 1. So if it is 2, then this is 4. Then it is 3, 6. So we can formulate as, we can see that relation is 1, 2, 2, 4, 3, 6, and so on. 4, 8, 5, 5, 10, 6, 12. So we can say that every natural number has one and only one image. That means this relation is a function.